I know that. I'm laughing at my. Wasn't that what you had? You like press the screen and you don't. Yeah. It showed the fucking being broken and passions.
Okay, so today we are doing inverse functions. Okay, so when we talk about inverse functions, it's kind of the exact opposite of whatever our original function is, which means that our x and our y's flip. So if I have an original function f of x that has points x and y, so it's a set of points, its inverse we say is f -1 of x, so it looks like an exponent -1, stop. Its points then are flipped. So all the x's here become the y's, and all the y's here become the x's. So the domain and the range of my original function flip. The domain becomes the range of my inverse, and the range of my original becomes the domain of my inverse. So of course, we're going to talk about that some more. Just remember that x in our original is our domain, y is our range. But then the y becomes the domain, and the x becomes the range for an inverse. So everything literally just flips. So looking at an example of this, let's say that I have a function that is a collection of a set of points. So if my original function f of x is the set of these points, we're going to go ahead and find our inverse set. Hold on. No, so in an original function, whatever we plug in is our domain. Whatever we get out is our range. I'm just showing you how they flip. Yeah. So let's say for this example, I have this set of values that is my original function f, and I would like to find what my inverse function f -1 is. So what did I tell you happens when we have points in original function and then I turn to look at its inverse? What happens to those coordinates? They flip. So that means my inverse has a set of points that starts with 2 and -6 because my x and my y here flipped. And then has -1, -5. Again, my x and my y just flipped. And then 5, -4. And then 0, -3. So literally, my x's and my y's just flip.
Wait, that's it?
Well, for this part, yes. Yes, Brandon. No, so that is just how we notate inverse, yeah. That -1 is, we don't consider that an exponent here. This just means inverse of whatever our f function was. Okay, so this is the notation for a function inverse. Okay, and then we can find domain and range the same way. My domain is going to be the set of all of these x values. And my range is going to be the set of all of these y values, just like before. So we've already done domain and range from a set of values like this. I don't feel the need to go over it again. So what happens if we're given a function that's not a set of points? Let's say specifically I've been given the function f of x equals -2x minus 2. And I would like to find the inverse for this function. The first thing we're going to do is we're going to replace f of x with y because it's equal to that. They mean the same thing. Once we have a y and an x in our function, to find the inverse, I flip the x and the y and solve for y. So that means for the inverse, my y's become x's and my x's become y's. So to start out, I now have x equals -2y minus 2. And then to find my inverse, I'm just going to solve for y. So I want to get y by itself. So what's the first thing I need to move in this green function in order to get y by itself? Say it, Pfeiffer. This minus 2, I need to move over to the other side. So that means it's going to add over. So now I have x plus 2 equals negative 2y. Again, my goal is to get y by itself. So divide by negative 2 because I have a negative 2 in front of my y. Which means that y equals x plus 2 over negative 2. So that is my inverse. That's not how we write our inverse, though. We go back to whatever our original notation was, and then we put a negative 1 on the function. So the way that I formally write my inverse is f negative 1 of x is equal to x plus 2 over negative 2. So we flipped our x and our y, and we solved for y. That's all we had to do here.
When will we ever use this?
In real life, absolutely never. But this is building your frontal lobe.
What is it used for?
What is it used for?
Is it, yeah, like the purpose of theoretic?
The theoretical purpose is that it cancels out whatever our original function was. So if I put something into this and I need to solve it or cancel it, I know I can use the inverse for that. There are other applications for it as well, but that's the fundamental purpose of an inverse. Yeah, chemist, engineer, stuff like that. Again, in everyday life, you will never use this. I'm the first to admit that. However, it does help build your cognitive thinking abilities. Okay? So let's go ahead and do another one. This time, I have the function h of x, and it is equal to 2x plus 5. And I would like to find the inverse. I can't find the inverse until there's an x and there's a y. So what's the first thing I need to do here? Replace the h of x with y because they mean the same thing. Then to find the inverse, I need to flip what? The x's and the y. So anything that is a y here becomes an x. Anything that is an x here becomes a y. So this gets rewritten as x equals 2y plus 5. And then what's the goal here? Solve for y, so get y by itself. So Madison, what's the first thing I'm going to have to move? The 5. So how do I move it around? Subtract it from both sides. Good. So that means I end up with x minus 5 equals 2y. Carly, what do I do next? Divide everything by 2. And I'm left with y equals x minus 5 over 2. That's not how we formally write our inverse. Our function here is h, so it's going to be h negative 1 of x is equal to the x minus 5 over 2. You should keep your function name the same, but no, if you have the inverse correct, it won't count that wrong. How do we feel about that? Anybody super duper confused by any of this? It gets a little bit more complicated if we have more x's in here, but this is the fundamental process, yes. Not quite. Okay, let's do another one because sometimes one's in the numerator and one's in the denominator and it can't be. It actually would make it more complicated to do that. So let's do one more. Oh, actually we'll do a couple more, but this time I have the function f of x is equal to 2x minus 10 over 3. Emily, what's the first thing I need to do? So f of x has to equal y, right? So I get y equals 2x minus 10 over 3. Then what do I do to start the inverse, Kaylee? Right, x equals 2y. Keep going. So everything that was a y becomes an x, and everything that was an x becomes a y. So I literally just flip-flop them. So that becomes x equals 2y minus 10. And now my goal is to solve for y, or get y by itself. Grant, what's the first thing I need to do that? Well, we switched x and y already, so I'm good there. What's the first thing I really don't like over here? The 3. So how do I get rid of that 3 from my denominator? Multiply both sides by 3. Perfect. So we always look at the first thing that we don't like, and that should be the first thing that we cancel out. So now I have 3x equals 2y minus 10. No, we multiplied, well, yeah, because there's only an x over here on the left. There wasn't anything else over there. If there was something else over there, we would have multiplied everything by 3. Camden, what do I do next? Nope, before that.
Oh, yeah.
Perfect. We're going to add the 10 over to the left, and I get 3x plus 10 equals 2y. Then what, Heath? Divide by the 2. And when I do, I get 3x plus 10 over 2 equals y. Technically, if you wanted to, you could split this answer up into 2 fractions. Okay, so this is equivalent to 3x over 2 plus 10 over 2, which is 5. So these two are the same thing. I prefer to leave it this way. Some of you might like to simplify it this way. It is entirely your choice. Okay, just know that these two are the exact same thing. On this one, we just split it up into 2 problems and divided each by 2. So again, we still have to write our inverse formally. So it's going to be f negative 1 of x equals 3x plus 10 over 2. Or the 3/2 x plus 5, if that's the one you prefer. Yes.
If the 3 were to be a 4 instead, we just put it as 2x plus 5?
Yes. So you split into 2 fractions and then reduce the fractions. 3/2 didn't reduce at all, so I couldn't do anything with it. But 10 over 2 reduced to 5, so that's what I did. You should always reduce the fractions as far as you can go if that's the way you choose to do it. You can leave it this way. This one is 100% okay as well. Questions, concerns, or issues so far? Let's do another one. I'm actually going to let you try this one on your own. Okay, you've been given the function g of x equals negative 3x minus 6 over 4. And I would like for you to find the inverse of this function. you're working through it, this is how I ended up solving it. Go ahead and check your work with mine. See if either one of us made a mistake. So far, how are we doing with it? Okay. Show of hands who's already finished and you got the same answer as me. Okay. Anybody super confused by anything that we're doing right now? Do we all see how it works out? We're going to do one more example and then I'm finished with the notes. Okay? Are we ready to move on to the next example? I don't want to move on if somebody's still writing. Madison, are you done, honey?
Yeah, I'm done. I accidentally put 7 instead of 4.
Yeah, that happens a lot. That's okay. So the last thing that we're going to do is we're actually going to answer a question yes or no. So the question is, given two functions, are the functions inverses of each other? Okay, so given f of x equal to negative 2 minus 4/5 x and g of x equal to 10 plus x over 5, we're going to determine if these are inverses of each other. Say that again. So when we take the inverse of either one of these, the answer is the other function. So if I take the inverse of f, whatever answer I get should be g if they're inverses of each other. If I take the inverse of g and I get the answer that is f, or what's left is f, then they are inverses of each other. You need to check both ways. It has to work both ways for this to work. Okay? So the first one we're going to do is we're going to start by taking the inverse of f, and we're going to see if it matches what our g function is. So I know the first thing I need to do if I'm trying to find the inverse is I need to change my function notation f of x into a y. So this becomes y equals negative 2 minus 4/5 x. Then I need to flip my x and my y. So this becomes x equals negative 2 minus 4 over 5 y. And now I need to start isolating my y value. What's the first thing I need to move here, Heath? The negative 2, right? I need to move that over to the other side so it becomes a positive. So I have x plus 2 equals negative 4 over 5y. Now what do I need to do? What don't I like about this? So I need to get rid of the denominator first. How do I get rid of something that has a 5 in the denominator? Multiply both sides by 5. Good. So when I multiply this side by 5, my 5's cancel. Then I multiply this entire left side by 5, not just one function or one term. That becomes 5x plus 10 equals negative 4y. And now what do I do? Divide everything by negative 4. And I'm left with 5x plus 10 over negative 4 equals y, which means that that is my inverse. How do you know they're not inverses of each other, Ebony?
Because in gx is 10 plus x over 5 instead of 5x plus 10 over negative 4.
Correct. So my inverse did not match my g function, which means they are not inverses. If we find one way that doesn't work, we don't have to test g still. You can as a practice if you wanted to find the inverse of this, but since this one failed, we don't have to test the other one. Yes? It doesn't matter which one you do first. I picked f because it was on top, but you could have tried to take the inverse of g and see if it equaled what our f function was.
So if it doesn't work.
So if you took the inverse of this and it didn't equal my f function, it can't work. Yeah. It doesn't matter which one you choose to do. I picked F because it was on top. Ariana.
When you're done talking, scroll up for a little bit.
Yeah.
I think I would be.
Okay, I'm 100% done. So if you guys don't have any questions for me, this is it for the notes. And your homework is the Unit 6 mid-unit review that's posted on Canvas. How far up do you need me to go, honey?
Just where the answer is. I didn't.
Okay, there you go. Yes, Camden.
Oh, I have a question.
Give me 1 second. Do you guys online have any questions for me?